Welcome back, everybody. We are doing the mean cell residence time math problem as the very first new math problem for the activated sludge series. Now, I have done this already on my channel. Some of the older subscribers might say, wait a second, didn't you already do this? I did, but the lighting was awful. I was just learning how to do YouTube videos, and it looked different on my phone before I uploaded it, and then it was like super dark, and it was on the old whiteboard style, and I like this new, cleaner, updated style. And for a math problem that's so important, I think I should redo this math problem. I'm going to redo the sludge age as well because it was kind of in that same dark environment. So getting to the MCRT and what it is and why it's important. So it is probably the most important process control equation we do in activated sludge. It kind of tells us how old our sludge is, but it's not sludge age. It tells us how long a microorganism in theory has stayed in the secondary system. And it's a way we use this number to tell us what we're doing in activated sludge. Say I have an MCRT of 3 days, probably not nitrifying. Say I have an MCRT of 12 days, I'm probably nitrifying and denitrifying. It's probably a biological nutrient removal or an extended aeration of some kind. So that's how we use this. And this math problem is a California grade 2 level math problem, which is a lower level. And this tells us what our MCRT is. Now, as you get into, you need to master this because as you get into grade 3, what you need to do with this math problem is, I'll circle it, you need to actually find the wasting rate. That's how you can change your MCRT. So like a grade 2 problem like this tells you how to find your MCRT, and the grade 3 math problem would tell you how to, you have a target MCRT, what wasting rate would you use, okay? And we'll go over that at a later time. Maybe in a few weeks I'll publish that one. Okay, so let's first break down the core of an MCRT. It is, I'm going to write the equation, I'm going to make a little bit of a point here. MCRT equals pounds of TSS or MLSS in the secondary system. Now, I did a video on this, TSS equals MLSS. I did a whole video on this, let me see, months ago about how when we do laboratory work, there's not an MLSS test. You find your MLSS test, you run a TSS test. To find your MLSS concentration, you run a TSS test. So it's the same thing. And so for the sake of our math, I think some people get confused when they're asked for MLSS. We're talking about TSS. So go check out that video. I'm going to put it in the links below. Also, I'm going to, at the very end of this video, what will pop up on your screen is a little chat I had with the camera, sludge age versus MCRT. It is an important distinction. Go watch that. I'm not going to regurgitate that all here. The other thing is, if you don't know how to do a pounds formula, links below, go check it out. Okay, I think that's all the videos I'm going to try to reference in this one. So pounds of TSS in the secondary system divided by the pounds of TSS or MLSS in the WAS plus the pounds of TSS leaving the plant in the effluent, okay? If you really break this down, what do I need for the pounds formula in the secondary system? I need the volume of the aeration basin in the secondary clarifier. If I need to figure out the pounds in the WAS and the pounds in the effluent, we're talking about flow, right? The effluent flow rate, the WAS flow rate, volume over flow. This is one big detention time formula. I might have blown some minds there. And I wanted to make this point because when we get into wastewater treatment, the core of what we're doing is how much stuff we have to deal with, or what we're using, divided by how much time we have to deal with it, okay? So the volume over flow is the detention time formula for water, but the MCRT is the detention time formula for biomass, okay? So I hope that helped people kind of understand that when we're really just talking about how fast it's moving through and how much of it that we have to deal with. That's really it. Okay, hopefully that was clear. So let's plug our values in and figure out this math problem. So MCRT equals pounds of TSS in the secondary system. Now the state of California conversion sheet, which I'm not a big fan of, would have you do 2 pounds formulas up here. Pounds in aeration plus pounds in the secondary clarifier, but you do not need to do that. All you need to do is take your aeration volume plus your secondary clarifier volume and add them together, because the MLSS concentration is the same. If you were to take the sludge blanket at the bottom of the clarifier and stir it up, mix it up, it would be 3,200 milligrams per liter. It's more concentrated on the bottom because we have had liquid-solid separation, which we do not get in aeration. Everything's constantly being mixed around. But that's what's going on. And so I think a lot of people get tripped up right here when and they leave out the secondary clarifier. You should definitely have the secondary clarifier in there. Okay. So what I like to do is take the 1 mg plus 0.5. So if I was to take this and do it like this, 0.5 mg, I would have 1.5 mg. Okay. So coming down here, 1.5 mg times 8.34. I'm doing a pounds formula times 3,200 milligrams per liter. All right, divided by our pounds of TSS in the WAS, which our flow rate is 40 GPM. So let's just do a quick dimensional analysis or conversion factor method to get that to MGD, 40 gallons per minute, times 1,440 minutes in a day. So now we're gallons per day times 1 million gallons per mg. If you plug that in your calculator, it should be 40 times 1440 divided by 1 million gives me 0.0576. So I would actually round that probably to 0.058 mgd. Okay? So coming down here, 0.058 mgd times 8.34, bit of a lag on my pad here, times 7,000 milligrams per liter in the WAS. Plus, sorry, hitting buttons on my stylus here. Now I got to figure out in the TSS effluent. So I've got 2.8 mgd is my plant flow. That might also be set as plant flow, not effluent flow. Times, not plus, sorry, times 8.34 times 7 milligrams per liter. Now I had a supervisor once who said, if you don't waste on purpose, you waste on accident. He called it wasting over the weirs. It was kind of funny, but he's right. Whatever TSS you can't manage in the plant through wasting will go over the weirs. So if you've got, and the reason MCRT is so important is it can kind of tell you what's going on in the plant. It's telling you how old your sludge is, in essence. If it's younger, you're probably not doing very much aside from BOD, like 2-3 days. You're probably just doing BOD TSS removal. If you're doing 11, 12, 13 days, you're doing biological nutrient removal. Okay, you're nitrifying, you're denitrifying, these kinds of things. If you find yourself in a conventional activated sludge plant and your MCRT is 11 days, you need to waste more. If you find yourself in a BNR plant and your MCRT is 3 days, you need to waste less. That kind of stuff, okay? What I'm going to do now is I'm going to go ahead and work this problem out. And because these are down here, you do this math problem, and then you add them together. You don't go straight across, order of operations here. So I'm going to bring it down here, MCRT equals, so we'll do the top first, 1.5 times 8.34 times 3,200 equals 40,032 pounds in the secondary system, pounds of TSS in the secondary system, okay? Divided by 0.058 times 8.34 times 7,000 milligrams per liter, 3386 pounds per day WAS plus 2.8 times 8.34 times 7 is 163 pounds per day in the TSS. So this is all the solids leaving the plant divided by all the solids in the secondary system. Okay, simply put. So this is going to just carry this over, 40,032 pounds divided by 3386 plus 163 should give me 3,549 pounds per day. Pounds cancel out. 40,032 divided by 3,549 gives me 11.27. I'll call it 11 days. I'm probably nitrifying. This is probably a BNR plant. Okay? 11 days MCRT. That is how you solve it. Now, you need to master this because all we've done here is figured out what our MCRT is. Grade 3, what you need to do is you need to figure out how to control your MCRT. Okay, and that's using that wasting rate calculation, which we'll do later. But all I can do right now is figuring out what my MCRT is. The advanced portion of this problem is I have a target MCRT and I need to figure out what my WAS pump should be set at. okay? And we will go over that at a later time. I hope this helped. I hope this version was better. It definitely was better than my one I did months and months ago in the dark, cave I was in. I will put this in the links as the activated sludge series rolls out. This will be in the full conceptual video. This will be every one of those videos. There's so much math when it comes to activated sludge, and all the math problems will be in the videos. And I'll kind of release them as I release the videos. I plan on doing like an SVI video, and we'll do a set solids test. I plan on I don't have the setup here to do TSS. I outsource all those, but maybe we can visit a lab and see how they do a TSS test. That might be something cool we could do. There's all sorts of great things I'm thinking of doing with this, but it's just going to take some time. This is going to be a big project. So anyway, thank you for watching. I hope you got something out of this. If you did, please like, subscribe, pass to your friends. Let's help folks get certified, and I'll catch you guys in the next one. Take it easy.